Assalamualaikum and good day. Today kita akan proceed lagi, continue with last week chapter 6 statically indeterminate structure. We're going to look at example number 2. Figure below is a multi-span beam with E and I being constant along its entire length. Determine the reaction on each support and draw BMD and Sfd. The figure given here, so you're going to draw the Sfd and Bmd based on this figure using the statically indeterminate method. From the figure, we're going to find the stiffness factor, okay, for each beam. Therefore, since we have this kind of beam, which is A, B, B, C, okay, so we need to do KAB and KBA because we need to transfer or distribute the moment to the support of the beam. That's why kita ada KAB and KBA, KBC and KCB. Therefore, for KAB, it must be equal to KBA because it is the same beam. Look at the far end support. For KAB and KBA, the far end support is pin support. Okay, when it is pin support, you know the formula for the stiffness factor is 3EI over L. That's why 3EI over L here. And then you just fill in according to this factor, fill in the value of L. Since also dalam soalan ni, it is mentioned that E and I being constant means that the modulus of elasticity and the cross section of the beam sama. So tak ada masalah, tak ada perubahan throughout the length of the beam. That's why kita ignore sebab dia kata constant maksudnya sama. Kita tak masukkan value EI ni Then you just calculate, you will get 0.5 EI. This one over 2, right? And for KBC, it must be equal to KCB. Look at the support again. The far end is fixed end. Therefore, the factor going to be 4EI over L and just replace the length of the beam 8 meters. So it becomes 4EI over 8 here. Then you calculate, you will get 0.5 EI. Then for the step number 2, we're going to calculate the distribution factor for each beam. First, we do for distribution factor A to B. Okay, AB, so it means that A to B. KAB divide by KAB. Because we are doing the distribution factor for AB, therefore the stiffness going to be KAB. But what you divide down here is based on what exactly the beam that stay on the support. Dekat support A ni, you look at the first alphabet support A ni just ada satu beam saja, which is beam AB. Jadi dia perkan dengan beam AB to whatever that on this support. That's why 0.5, then you just divide with the same value 0.5 EI, just slash this one, you will get 1. And for distribution factor B to A, KBA, because we are calculating for distribution factor BA, so stiffness is BA also, divide by KBA plus KBC, because when you refer to this beam, we are doing KBA, which means that we are looking at support B. So when it is support B, you have two beams on this support B, which is beam BA and beam BC on this particular support. Therefore, the total stiffness DFBA, okay, distribution factor B to A ni, okay, total dia kat sini adalah KAB plus dengan KBC. That's why down here it is KBA plus KBC. Then you just calculate 0.5 EI. It is so 0.5 plus 0.5 become EI or 1 EI lah. Okay, so 0.5 bahagi 1 you akan dapat 0.5. For distribution factor B to C. So when B to C, the K must be KBC lah. Okay, and divide with total stiffness of beam yang dekat support B juga, because you look at the alphabet kat mana yang you tengah calculate the support. Support dekat support B memang masih lagi ada beam A, B ke A dan B ke C. The total stiffness is KBA plus KBC. Just ambil 0.5 EI divide with 1. That's why you dapat 0.5 divide by 1. Then you will get 0.5 also. For distribution factor C ke B, so KCB, yes we are doing for CB, divide with total stiffness of beam at support C. Okay, look at the first alphabet there. So dekat support C, it is fixed end. So as what I have mentioned in last week punya video recording lecture, when there is fixed support, there is like another beam that its length is infinity. That is in structure memang macam tu. Therefore total stiffness at support C is KCB plus dengan infinity. This is the one so KCB plus infinity, macam mana pun you tetap akan dapat kosong, because any numbers that deal with infinity memang will automatically become 0. Kita check if let's say for AB the end support is pin or roller, mesti 1. And if let's say you plus distribution factor BA plus dengan BC ni, these two you plus together, they must be equal to 1. And for fixed end support, the distribution factor must be 0. Dia punya far end, if let's say there is a fixed support, the distribution factor will be 0. For fixed end moment, we need to, as usual kita kena assume dulu the direction of the moment, whether it is counterclockwise or clockwise. The way we assume memang sama for every support, doesn't matter support apa sekalipun, at the far end or in the middle, you must assume like this. Okay, jangan assume cara lain. This is the way the direction goes. For FEMAB, this is from point A to point B. This is point load. So when it is point load, the formula is PAB square over L square. The P is 80, okay, and negative because we assume this one for FEMAB it is counterclockwise, that's why it is negative. So 80 kilonewton, and you have to times the value of A. So A ni, this one is A and this one is B. So A 2 meter, B 4 meter, and then you power of 2 and divide by 6 meter the overall length of beam AB. The value is negative 71.111 kilonewton meter. For FEMBA, now this is the one that I mentioned in example 1. You have to be careful on this, because this one from B to A, so you have to look at from this side. Okay, so from this side, value P ni masih sama and it is positive lah, since we assume that it is clockwise. Tapi here, if you look at the value of A and B, dia terbalik, because this one become A, you have to look at macam from B, you tengok, so you jumpa 4 meter dulu, so this one become A, and this 2 meter become value of P, and divide with the total length of beam AB, then you get 35.556 positive, sebab kita assume dia clockwise. And for FEMBC, it is negative again, okay, sebab counterclockwise. Beam BC, you have UDL on the top of the beam, So when there is a UDL, the formula become WL square over 12. So just fill in the value of W 15 and the total length of beam BC 8 meter divide power of 2 divided by 12, then you get 80. For FEMCB, WL square over 12 again, because this is actually the same beam. It's just that it become positive because we assume that from C to B it is clockwise. Therefore, it is 80 kilonewton meter positive. Then we move to the next step, which is the distribution table. For the distribution table, again, you have to do the same table as what you did in example number 1. Fill in all the values for the distribution factor for the fixed end moment that you dapat earlier, which is this one, must be according to the member. So kalau A, B, then you fill in according to this. And same goes with the FEM. Ikut juga masukkan this value inside this distribution table. Then we can start to calculate starting from the distribution. Okay, this one is distribution and this one supposedly carry over. For distribution, the formula, as you know, you take FEM, you times with the distribution factor and you darab dengan negative. For member AB, you take the FEM, which is negative 71.111, and you times with the value of TF 1 and you times with negative, so it becomes 71.111 positive. And for member BA, you just take the value of AM, you plus these two together, negative 44.444. From this value, you just times with the DF of BA, which is 0.5, and times with negative. So here I dapat 22.222. And same goes with BC. Since value the DF sama, which is 0.5 juga, so that's why value of distribution here pun sama. For distribution of CB, 80 you darab dengan the DF, which is 0, and times with negative, so it becomes 0. Okay, we are done with FEM. Then we move to carryover. For carryover, you just take the distribution value, divide by 2. But we must look at the support of the beam at the beams. At the point A, that is pin support. So when pin support, okay, doesn't matter. You boleh carry inside, you boleh carry inside. Tak kisah. Kalau carry inside any support outside, you can carry over inside. Tak ada masalah. But when you want to carry outside, you must have a look at what support on the outside. So at the point A here, this is pin support, you cannot carry over. But for point C here, this is fixed support, so you can carry over the load to that support. So that's why you boleh bawa moment tu ke C, sebab fixed support boleh resist moment. For distribution here, you boleh carry over. So when you carry over, you must remember to divide it by 2. So you divide by 2. For this one, you cannot carry over. Okay. BA, you cannot carry over to AB. So it becomes 0. BC, you boleh carry over to CB. Divide by 2, then you get 11.111. And for CB, you can carry over to BC, but since the value masih lagi kosong, so you just get 0 lah. Even 0 divided by 2 pun, it's still 0. Then we move to the distribution. Again, since kita punya value masih lagi belum 0, so you must repeat these steps. All of these steps, which is distribution and carryover ni, kena repeat sampai you dapat value kosong. For distribution, you take the value of carryover, betul-betul atas ni okay, and then you times with the distribution factor and times with negative. So CO, which is 0 for AB, times 1 times negative, you still get 0. And for BA and BC, whatever here, you must plus it together because they share the same support. So you kena campur these two value. So masih lagi 35.556 35.556 you just times with 0.5 and times with negative for BA. So you dapat negative 17.778 and same goes with BC. Since the value of distribution factor ni sama, jawapan dia pun sama lah. For CB, this 11.111 times with 0, the distribution factor, and times with negative, then you get 0. Okay, so masih belum 0 semua. So kita move to the carryover. So for carryover, you boleh carry over. Kosong you boleh carry over to BA. AB you boleh carry over to BA. BA cannot carry over to AB, so it becomes 0. BC can carry over to CB, but you must divide with 2. 0 can carry over to BC here, but even if you divide by 2, value dia sama, masih kosong. We move to the distribution again. So because kita punya ni belum completely 0, for here it is carry over times distribution factor times with negative. You just ambil je CO ni, you darab lah dengan DF. Masih kosong because kosong kat sini darab 1 kosong, darab negatif kosong jugalah. And for this one, you plus these two together, you will get 0 also. So 0 darab 0.5 darab negatif masih kosong, and kosong darab 0.5 darab negatif masih kosong. So kosong, kosong, kosong. Last kali for CB, you have negative 8.889. You times with the value of distribution factor, which is 0, so it becomes 0. So 0 times negative, it is 0 also. So semua ni dah kosong. So when it is 0, we can stop. So we stop. We can just calculate the final moment. You just add all those starting from here. Campurlah semua ni. Okay, you plus all together starting from FEM, then you will get the final moment. Do it for every column. Okay, we are done with distribution table. Now we can move to reaction. For reaction, it is better for you to actually draw this because you nak lebih senang you tengok je ni. So you bahagilah, you do it for AB first and then later on you buat for BC. So I do for AB first. For AB you tukarlah all those support tu, put the reaction which is RA and RB1. Don't forget to include juga those that you calculate dalam this distribution table. This value, don't forget to put inside the calculation for reaction. Okay, because here that you get the value for BA, it is 75.556, which is positive. So positive means that it is clockwise. So that's why here I draw clockwise. 75.556. Okay, to calculate reaction, I take moment at B. Distance must be from B. RA times with 6 meter, okay, which is the distance. And then, okay, done. And then you have 80 kilonewton times with 4 meter. Okay, it become minus because this is counterclockwise, is going to be to B. So they become negative. And then you have to plus. Don't forget to put the value of moment here because this is moment equation. Jadi moment kena masuk dalam moment equation. Therefore, when I solve this, I get 40.741 for RA. And then I can solve for RB1. Okay, I just use a simple force equation. Whatever clockwise, it is positive. And for Fy, whatever going up, it is positive. We have RA going up, so positive, minus 80 kilonewton because it is going downwards, so minus 80 kilonewton. And I have RB1 here that I'm trying to find the value. Okay, you just isi lah value of RA, then you will get RB1 value. The next is I do for the same thing for beam BC. Just copy B sampai C kat sini. Okay, copy all this. And then rename lah based on the support there. So I put RB2 and RC, and also I fill in this thing. I have the value of BC, moment at BC negative 75.556, and moment at CB which is 82.222. So negative 75.556 ni counterclockwise because dia negative 82.222 ni positive, it is clockwise. So jadi macam ni Okay, then I do the same thing again, do the moment equation. I take moment at C. Okay, typo. RB2, okay, going to C, U darab 8 lah because that is the distance. And I have UDL here which is 15 kilonewton per meter, which means that for each 1 meter it is 15 kilonewton load. So kalau 8 kilonewton, that's why I darab dengan 8 lah. So these two calculation for force and 4 meter is the distance because kita nak kira for moment, then we need to times the distance from the centroid of the load to the point, which is 4 meter, half of it. I have another moment here, 75.556, which is counterclockwise. Then I put here negative and plus with 82.222 because this is clockwise, tambah lah. Equal to 0 because of equilibrium, and I can solve the value for RB2. The next thing is kita boleh solve for RC just using this force equation. I have this RB2 value already, which is 59.167. Okay, and then I have another force which is UDL here, 15 kilonewton per meter. For 1 meter it is 15. So for 8 meter you just darab dengan 8. You tak perlu darab dengan 4 meter lagi because this is force equation. Ini bukan moment equation. Kalau you nak jadikan dia moment, you kena darab dengan distance. But this is force, so you just darab je dengan the 8 meter because this is UDL. I have another force here which is RC, the one that I'm trying to find. And don't ever include moment value dalam force equation sebab dia adalah force, dia bukan moment. Then I can get the value of RC. So after that, we can proceed to draw the Sfd and Bmd using the input that you calculated earlier. For Sfd, I need to label. Okay, Sfd, kita ambil value daripada reaction yang you kira tadi semua, refer balik, masukkan all those reaction that you get the RA, RB1, RB2 and RC to this figure letak kat atas ni, masukkan this one RA, RB1, RB2 and RC. And also jangan lupa you calculated moment earlier dalam that distribution table. Also include value-value ni semua. Support A kosong, so that's why I tak lukis lah. Then kita draw. For RA it is 40.741 going up. Okay, therefore dia naik atas lah. Here 0 Then there is no load at all, so become straight line. Then there is a 80 kilonewton load, therefore 40.741 minus with 80, then you get the negative 39.259. No load at all after that. Okay, so it becomes straight line again. And then you see there is a RB1 which is 39.259, so dia naik jadi kosong balik. And then for RB2, the next reaction the next force yang you nampak 59.167, so it's going up again. You see there is a UDL 15 kilonewton per meter for 8 meter. Therefore 15 kilonewton per meter you have to times with 8 meter. You akan dapat 120. So this one adalah UDL which means that dia distribute evenly, jadi dia turun sikit lah. Okay, that's why you dapat this garisan yang menurun macam ni, slanted ya. So 59.167 minus with 120, it is negative 60.833. And then for RC, you see the next force 60.833 positive, going up sebab dia naik atas, jadi dia pun naik atas balik pergi kosong lah. Then it will what you can see here, it will start with 0 and end with 0 baru betul. Kalau tak, something wrong somewhere dekat Sfd you. Okay, so after that kita boleh calculate BMD. To calculate BMD, what you need to do is you need to calculate the area of all rectangles and triangles that you see in this Sfd. Okay, so for this one 40.71, I boleh kira area rectangle tu. So I can name it, this is 1, this is 2, this is 3, this is 4. Okay, for number 1, I jarang kira macam ni sebab I terus kira pakai calculator tapi because this thing tak ada markah, I tengok the Sfd and Bmd diagram, I don't give marks to this calculation Ini you belajar masa part 1, which is very easy. So for number 3, ini adalah triangle. So for triangle, the way we calculate it, sebab kita nak cari dulu, because this 3.944 ni I dah kira kan, but you tak tahu sebenarnya value ni berapa So here I just put X first, and for this one should be panjang ni mesti 8 minus X kan, because the panjang BC tu is actually 8 meter. So kalau this one you namakan dia lah X, so mestilah balance itu adalah 8 meter tolak dengan value X. Kalau X is 59.167, then 8 minus X equal to 60.833. Then you just cross multiply minus with 59.167x. Okay, we can solve this. It is tak muat 120x equal to 473.336. Then I dapat x is equal to 3.944. That's why here I put 3.944, and the balance here should be 8 minus this 3.944. So it is 4.056. Then kita boleh kira number 3. So for number 3, it is triangle. So 1/2 times 59.167, and you darab dengan the width of the triangle, which is 3.944. And number 4, 1/2 times 60.833 and times with the width of the triangle, which is 4.056. Then we can solve all this. So this is yang I kira dengan tulisan saya buruk ni. We're going to start with 0. So since depan ni pun, if you see this example is different from example number 1, because at the front here the moment is 0. Okay, so when it is 0, so they're not going anywhere lah. They stay at that point which is 0. And we go to the first area. I dapat 81.482. That's why I mark there. Okay, label kat situ juga. And then for the second area, it is 157.036. So 81.482 minus Why we need to minus? Because area number 2 ni dekat bawah kosong Sfd line Sfd line yang kosong tu dia bawah kosong. So bila dia bawah kosong maksudnya dia negative area Then 81.482 minus 157.036. Then I get this value, which is negative. And I see there's triangle here, which is positive. at the positive area. So we plus with 116.677. So negative 75.554 plus 116.677. Then I dapat 41.123. Last kali another triangle here. 41.123 minus 123.369. Kenapa minus? Sebab area ni negatif So dekat bawah, jadi kita minus. So bila minus, you pun dapat negatif 82.246. Okay. Supposedly dia akan end dekat kosong. Okay. Sebab Sfd or Bmd, when we say that it is equilibrium, it should end dekat kosong. Okay. Sebenarnya dia end dekat kosong. Why? Because if you see on top here, okay, you have another value which is 82.222 positive. Okay, so positive, so 82.246 plus this 82.222. Supposedly, kalau our calculation we are not using like 3 decimal places, you are using more decimal places baru dia tepat lah. Okay, especially when we calculate for value of x here. So kat sini pun kita ada round up some value or round down some value. That's why kita tak dapat like betul-betul kosong kat sini Tapi this is acceptable because the difference is sikit je, around 0.024, which is a little bit here. Beza dia, so acceptable So dia supposedly end dekat kosong lah. Okay. So we are done with example number 2. Then we move to example number 3. From the beam shown, use the moment distribution method to determine all reaction at support and also draw the Sfd and Bmd again. This time, if you look at the figure here, the end support is just pin and roller so now no fixed support. As usual, we're going to start with the stiffness. So calculate the stiffness factor using the KAB equal to KBA. Because this is beam yang sama the same beam, therefore dia sama lah value dia since far end support dia sama. So for KAB and KBA, this is pin support. So kalau pin support, roller support, formula again sama 3I over L. Just fill in according to the this 3I over L. Just masukkan L, which is 3 meter length of the beam. Therefore, I dapat EI. For KBC, it must also be equal to KCB. Okay. 3I over L again because this is far end there is roller support. So when it is roller support, it is 3I over L. And the length of the beam is 4 meter. You just divide with this and you will get 0.75 EI. We move to the second step, which is distribution factor, DF. So DF AB is the stiffness at AB divide with the stiffness at support A. Here at support A, we only have one beam, which is beam AB. That's why we divide with KAB only, or stiffness at AB only, equal to 1. Okay, this one can you cancel out. For distribution BA, the stiffness is KBA lah. Okay, divide with total stiffness at support B. So at support B, if you look at the figure, we have beam BA and beam BC. That's why you divide with KBA and plus with KBC KBA, you pun check dekat atas ni, you tengok it is EI, and plus with KBC 0.75 EI. Okay, bila you campur, you akan dapat EI 1.75 EI. Okay, therefore you akan dapat 0.571 lah. Okay, ini 1 EI tu 1 EI. So 1 bagi 1.75, 0.571. For the FBC, so KBC divide with KBA and KBC again sebab kita akan tengok dekat support B juga. Okay, so you ada beam BA and BC. Okay, jadi you kira 0.75 EI divide with 1.75 EI. You get 0.429. And for DFCB, so KCB divide with stiffness at support C. So stiffness at support C, if you look at here, this is roller support, so tak ada yang infinity tu because that one only applies on the fixed end support. Because of this is only roller, so you only have one beam here that sit on this support, which is C beam CB. So KCB lah. So KCB divide by KCB. Therefore, you akan dapat 1. That's all on the distribution factor. We move to fixed end moment. For fixed end moment, we have to look at what support do we have at that particular beam. FEM AB, here we only have UDL, which is 12 kilonewton per meter. So you know the formula is WL square over 12. But we must assume first the direction of the moment. This is how we assume. So for AB, it is counterclockwise. That's why I put negative here. Then W is 12 kN per meter. The length of the beam is 3 meter. Power of 2 and divide by 12. Here I get negative 9. And for beam B to BA, WL square over 12. The difference here, this is positive because we assume it clockwise. Okay, and then kira you akan dapat value dia sama je. The difference here, beam BC and beam CB. So for beam CB, if you notice, you ada dua load, which is one of it is UDL and another one is point load. So for UDL, WL square over 12. Since kita assume for BC it is counterclockwise, so you must put negative here. So WL square over 12. And minus again, okay, negative sebab counterclockwise juga, okay. You have also one point load. At the same beam, you have two types of load. Okay, jadi that's why ada dua. Masukkan ikut formula. So W12, the length of the beam is 4 meter. Power of 2 divided by 12. Negative and negative again, ataupun kalau negative dia jadi minus lah sebenarnya. 32 and the value of A is 3 meter because we are doing for BC, so you kena tengok dari sini lah. So you nampak 3 meter dulu, so you put it as A and 1 meter as B and then divide with the total length of the beam. Kat sini I dapat negative 22. Then I kira for CB sama je for WL square over 12 except that this one is clockwise. So that's why dia plus So here plus and this one also plus. 12 kilonewton per meter times 4 meter divided by 12, okay. And then for the point load, the difference is value A and B ni because this one 1 meter we're going to look at from CB So tengok dekat C lah. So bila you tengok dekat C, 1 meter ni jumpa dulu, so that one become A and 3 meter become B. Power of 2 divided by the total length of beam CB. I get 34 kilonewton. Typo meter. We going to do the distribution table. Just fill in again. Okay, I'm not going to like explain everything again on this one. So just masukkan DF, FEM according to whatever that you calculated earlier. I akan start dengan the distribution. So DIST is distribution. It should be FEM times DF and times dengan negative. So FEM is negative 9 for AB times 1. Okay, so negative 9 again and times negative, so it become 9. Dia akan jadi positive 9. For BA, you have to plus FEM together because it is at the same support. So 9 plus negative 22, negative 13. Negative 13, you have to times with the 0.571 for BA and times with negative. I get 7.423. I got this value. And for member BC, negative 13 again times with 0.429 the DF for BC and times with value of negative, and I get the 5.571. For CB, 34 times 1 and times negative become negative 34. So belum kosong, kita proceed lagi. We do for carryover CO. Okay, for carryover we must have a look at our beam here, how actually the support at the end. So you can carry forward inside, no problem, but to carry forward inside lah, carry over inside. But to carry over outside, you must have a look at the end support. This one is pin support, so you cannot carry over, and at C also it is a roller support, you cannot carry over. Therefore, for carry over, it is distribution divided by 2. So 9 you can carry over to BA, but you must divide it with 2, become 4.5. For BA you cannot carry over to AB, so it is 0. And for this 5.571, you also cannot carry over outside, cannot carry over to CB, so it becomes 0. And for CB you can carry over to BC, so you just divide it by 2. Then we do distribution again, sebab belum kosong lagi. CO darab DF and darab dengan negatif. For CO on top here, okay, kosong ni darab dengan 1 tetap kosong, kosong darab negatif kosong jugalah. Okay, and then this one don't forget to plus it together. So I dapat negative 12.5. Negative 12.5 you just times with 0.571 and you times with negative. So you akan sebenarnya kalau you dapat negatif 12.5, you darab 0.571, you dapat negatif 7.138. Okay, and then you darab dengan negatif, so jadi positif lah. Okay, and same goes with BC. Negative 12.5 times 0.429, you will get 5.363 negative and then you darab dengan negatif, so jadi positif and then for CB, the value of CO here is 0, so 0 darab 1 darab negatif, then it becomes 0 also. Okay, masih belum kosong, so kita akan carry over. To carry over, A, B can carry over to BA, so stay kosong but okay, BA cannot carry over to AB, so that's why jadi kosong here. And then for BC, you cannot carry over to CB, so kosong. And then CB, you can carry over to BC. Okay, boleh carry over tapi stay kosong So semua dah kosong. When it is 0, everything on that row is 0. You boleh terus kira for the final moment. Okay, so campur je all this thing together, then you akan dapat the value for final moment. Okay, value ni akan lebih kurang, but kalau you nampak value dia tak berapa sama Supposedly like example number 1 I explain should be kalau betul you kira value dia akan lebih kurang, tapi sebab kita ada round off, round up tadi, so that's why value dia a little bit different for BA and BC so you just bila you kira for reaction, you ambil salah satu value lah. Kalau you ambil, mungkin you ambil 28.061, okay, you ambil value ini, ambil salah satu number no problem, sebab sebenarnya dia betul tapi kita ada round off, round up tadi kan. Then we move to the reaction. This one I tak nak explain lah lagi. Okay, kat sini like I said, I ambil 28.061 for, wait, ini B. Okay, RB1 lah, and this one is RA. 28.061 I ambil, kalau you tengok dekat kita punya distribution table, I ambil value ni. Okay, value ni kiranya macam kan bila kita kira untuk beam AB, later on you kira untuk beam BC, you pakai je 28.061 tapi you negatifkan lah. Okay, supposedly sebab value dia sepatutnya sama tapi ada lari sikit kan, sebab kita ada round up macam tu Okay, kalau tengok kat sini point pakai value yang sama. Kalau tak sebenarnya for beam BC ni dia negative 28.066 kan, tapi ambil 61 juga Kita buat for beam AB first. So total moment at B I ambil equal to 0, which means that equilibrium. So RA going to B, you darab dengan dia punya distance, which is 3 meter, and then you have UDL 12 kilonewton per meter. So for 1 meter is 12 kilonewton, tapi beam you 3 meter, so you times with 3 meter, so this one is F force and the distance, which is from the centroid of the UDL, it is 3 meter divided by 2 so that's why it become 1.5, and it is counterclockwise sebab dia pusing macam ini. Okay, force loading kan dia turun bawah You have 28.061, which is moment. You kena masuk dalam this equation, equal to 0 due to equilibrium. So we can solve the value of RE, and we do the force equation to solve RB1. Okay, going up it is positive, therefore RA going up, reaction kita assume dia going up positive, minus 12 kilonewton per meter times 3 meter because of the UDL. All of this is force and then plus with RB1, which is the one that we're trying to find. Okay, so kita solve, then this is the value that I dapat. For beam BC, then this is RB2 and RC. RB2 times 4 meter, okay, darab 4 meter dia, sebab I ambil dekat C, minus with 12 kilonewton per meter because we have 1 UDL here, which is for 1 meter it is 12 kilonewton, so for 4 meter it is you kena darab lah dengan panjang 4 meter tu darab dengan 2 meter, distance from centroid of the UDL point load here kena masuk sebab dia adalah loading, jadi dia kena masuk dalam kita punya calculation. Minus with 32, nak pergi ke C is only 1 meter, and this is counterclockwise also, jadi negative and then don't forget to also include the moment yang you cari earlier dalam distribution table tu, which is negative 28.061, so dia adalah counterclockwise so bila you masukkan dalam you punya equation, so you put negative there, therefore RB2 is 39.015. Kita nak cari RC. For RC kita pakai simple force equation je RB2 minus with, you have 1 UDL which is 4 meter long, okay, 12 km per meter darab 4 meter, and then you have one point load minus dengan 32 lah sebab point load you pergi ke bawah, loading mesti turun bawah punya, and then plus with RC, then you boleh solve, you dapat RC. Reaction, kita pergi to Sfd and Bmd last step. Okay, for Sfd and Bmd is fill in whatever that you need to fill in inside this figure jangan lupa kalau you termis nanti akan salah that's why please kena lukis. Going up, okay, since we have reaction RA, okay, 8.646, and next you nampak ada UDL for 3 meter long, so 8.646 minus with 12 times 3 meter sebab 1 meter loading ni adalah 12 kilonewton, tapi loading you ada for 3 meter long, okay, jadi kena darab dengan 3 so 8.646 minus with 36 lah, so you dapat negative 27.354. You see there's RB2 which is 27.354, back to 0 again. Going up, you see there's RB2 which is 39.015, so mark here, and there's a UDL next for 3 meter sebab kita kena stop dekat sini sebab you ada satu point load dekat atas, you stop here So value dia sama je kat sini, 12 kN per meter juga, UDL yang sama So 3.015 minus with 36, then you dapat 3.015 minus with 32 sebab you ada point load, so turun bawah, so negative 28.985, and you nampak ada UDL balance dekat sini for 1 meter, so 28.985 minus 12 lah. Okay, sebab 12 kN per meter tu darab 1 meter 12 kN juga you have RC 40.985 going up, so back to 0, so akan end dengan kosong. That's for SFD. Next kita akan kira for BMD. Here I ada calculation dah, how do I get the value of X. So X I dah tak nak explain please tengok video I yang sebelum-sebelum ni, you akan faham. And basically this thing you dah belajar in part 1. For value 3 minus X ni, you ambil je 3 meter because of panjang beam ni 3 meter so minus dengan 0.721, you dapatlah 2.279 dekat sini. Okay, jadi you akan kira area dia. For the area 1, 2, 3, 4. So area number 1, so this is triangle, 1/2 times 8.646 and times with 0.721. For number 2, 1/2 times 27.354 and times with the width, which is 2.279. And number 3, this is trapezium. So kalau trapezium, kira macam trapezium 1/2 times 39.015 plus with 3.015 and times with the width, which is 3 meter. And number 4 pun sama, this is trapezium, 1/2 times with 28.985 plus 40.985 and darab 1. Kira berapa semua this is my answer so I dah kira all the areas 1, 2, 3, 4. We're going to start with 0. Okay, dekat depan ni pun you don't see any moment there, so masih kosong so bila kosong, okay, you nampak the first area which is 3.117. Okay, area tu dekat positive, which means the moment ni positive lah. Okay, and then the second area 31.117. So 3.117 ni minus sebab area number 2 ni negative. 3.117 minus dengan 31.17. That's why I dapat negative 28.053. Area number 3 positive here dekat atas so plus with 63.045, so I dapat 34.992. And then last kali area number 4 34.992, you minus lah dengan area number 4 sebab area ni negatif jadi when you tolak, you akan dapat 0.007, which is tak exactly 0 tapi sebab kita ada round up, round down macam tu, that's why kita tak dapat lah exact value kosong. Sebenarnya kalau kita betul-betul kira ikut the value yang kita kira pakai calculator tu kita tak ada round up macam tu, you akan dapat betul-betul tepat kosong semua. Okay, jadi this is kita punya Sfd and Bmd. Okay, just to I lupa nak bagi tahu awal-awal okay, ingat bila you tengok BMD ni, you nampak dia like curve all the way along this beam semua sepanjang 7 meter, dua biji beam, 2 buah beam ni yang 7 meter long ni dia curve sebab Ini adalah UDL. So BMD kalau ada UDL memang akan jadi curve. And dia punya Sfd akan jadi slanted bukannya straight line. Dia punya diagram macam ni Okay, please take note on that. Itu saja I think for today. Since kita dah done with example number 3. So in tutorial class kita akan buat latihan sama-sama. Alright, thank you so much everyone. Have a nice day. Stay safe, stay healthy. Bye.